A golfer strikes a ball giving it a velocity of 35 meters per second at 35 degrees. If the course is completely flat, how far will the ball travel before bouncing? So as we can see, the golfer is swinging at the ball and it lands some distance away from him. This is the way the ball travels in an arc like this, and this triangle comes from half this arc, from here to here to here. Now the values we already know is the 35 meters per second at 35 degrees, and we also know the y component of acceleration, which is negative 9.8 meters per second. Now to find the velocity in the x component this way, we must multiply 35 meters per second times cosine 35 degrees, which will give us 28.7 meters per second. To find the initial velocity in the y component, we must multiply 35 meters per second by sine 35 degrees, and this will give us 20.1 meters per second. And the final velocity, because we are only doing it this half, at the top will be 0 at the instantaneous moment it gets to the top. Now, this is the equation we will use. Final velocity equals initial velocity plus acceleration times time. Modify it so we'll equal time equals final velocity minus initial velocity divided by acceleration, giving us this 0 meters per second minus 20.1 meters per second divided by negative 9.8 meters per second squared, 2.05 seconds. Now since this is only the time it takes to get from here to here, to get the time it takes from here to here, we must double it, so the total time equals 2 times 2 times 2.05 seconds, which will give us 4.1 seconds. Now that we have the time, we can figure out the distance in the x component by velocity equals distance over time, modified to equal distance equals velocity over times time, and it will give us 28.7 meters per second times 4.1 seconds, which will give us 117 meters. Our unit check is meters per second times seconds equals meters over seconds times seconds over 1. These seconds will cancel out, giving us meters over 1, or just meters.